Welcome to Lesson 1.5, Adding and Subtracting with Fractions. Today we're going to talk about how to add numbers with like fractions, add numbers with unlike fractions, solve problems involving adding fractions, subtract numbers with like fractions, and subtract numbers with unlike fractions, be able to regroup to subtract with mixed numbers, and solve problems involving subtracting fractions. All right, so we have quite a bit of vocabulary. So again, I'm going to go through quickly. Make sure you get your term, definition, and example into your vocabulary notebook. And make sure to pause if I'm going too fast. All right, so a fraction represents a part of a whole. So if you had 4/5, that would mean 4 parts over 5 to make a whole. So fractions are showing us how many out of a total. It's different from a ratio. A ratio compares 4 to 5. For every 4 of these, there are 5 of those. In a fraction, what this means is I have 4 pieces out of the 5 that I need to make a whole cake. The numerator is the number in the fraction that represents the part. This is the number on the top of the fraction bar. Okay, so 4 is your numerator, and it tells you how many parts there are. The denominator is the number in the fraction that represents the amount needed to make a whole. This is the number below the fraction bar. Right, so 5 is the denominator in this case, and it tells you how many pieces you need to make a whole group. So when I have a whole group, so if I were to have 5 out of 5, that's when we get our whole numbers, and that's when we get into mixed numbers. A mixed number is a whole number with a fraction. This means there is or are whole groups in a part of a group. So what this means is you have 4 whole groups, and then you have 4 pieces out of 5 to make another whole group. An improper fraction is when the numerator is larger than the denominator. More specifically, when the number of parts is larger than the amount needed to make a whole group. So if I were to take that 5 and put it on top, it now means I have 5 parts over 4, meaning there are 4 pieces that I need to make a whole group. So I have more pieces on top than I do on bottom. So if I have 5 pieces total, that means that I can make a whole group of 4, so I should be able to make a mixed number. Unlike fractions are fractions that have different denominators. So like 1/3 and 3/4, any fractions that have different denominators are called unlike fractions. And like fractions are fractions that have the same denominator. So 2/3, 1/3, we could even say 4/3. That would still be a like fraction even though it's an improper fraction. So we could even put 4/3 on here. As long as that denominator is the same, it's considered to be a like fraction. All right, so we talked about when adding and subtracting fractions, it has to be adding apples to apples. So we have to be adding like fractions or subtracting like fractions. So when we get an apple and an orange, we have to figure out how to make them both apples. And since this is review, we're going to go pretty fast. So first I have to find the least common multiple of the two denominators. So here I have 4 and I have 5. Sometimes this is found just by multiplying the 4 and the 5 together. So the 4 and the 5. Sometimes though, you don't have to do that. Sometimes you can create a much smaller fraction if you find the least common multiple. So when you're finding multiples, remember these are your count bys. So 4, 8, 16, 20. Well, I know 20 is a multiple of 5, so that's what I'm going to use. So I have 3/4, and I need to change it to something over 20. And I have 4/5, and I have to change it to something over 20. The only way to make equivalent fractions, so we're not changing the fraction is just going to look a little different. We're just giving it a different costume, but it's still going to be worth the same thing. So it's like saying if I have 4 quarters, that's equivalent to having $1. Either way, they are the exact same value, they just look different. So to make equivalent fractions, I can either multiply or divide. And in this case, I know I have to multiply because I'm going from a smaller number to a larger number. So to go from 4 to 20, I multiply by 5. And I know that the rule is what I do to the bottom, I have to do to the top. So on top, I get 15. And then I know to go from 5 to 20, I multiply by 4. So I do that on top, and I get 16. So now I've made my two equivalent fractions. So 15/20ths is the same thing as 3/4. It's just now it's a like fraction with 16/20ths, which is the same thing as 4/5. So I can put these two together, and now I can add them. When we add fractions, we do not add denominators. So it's like when you are putting together a snowman. A snowman is built in thirds. So you have the bottom, so that's 1/3, 2/3, 3/3. All together, this makes one whole snowman. But each of these pieces together is a third. If we were to add denominators, all of a sudden we would have ended up with 3/9 and been back to 1/3, which would mean we'd only have that much of a snowman. So you're just adding to the group. You're not making, if you add your denominators, you're making the whole group larger, and that's not what you're trying to do. You still need 20 to make a full group, but now you have 15 pieces, plus you get another 16, which means you have 31 pieces. So I have 31/20ths. Well, I know that I cannot leave it like this because it's an improper fraction. And remember, changing it from an improper fraction to a mixed number is not part of simplifying. So what this means is I have 31 pieces and 20 make a full group. So I'm doing my long division, so I know the divisor goes on the outside and the dividend goes on the inside. And 20 goes into 31 once. I subtract 20 and I get 11, so I have a remainder of 11. So what this means is I made one whole group and I have 11 pieces left out of the 20 that I would need to make another whole group. So my answer is 1 and 11/20ths. And 11 and 20 cannot be divided by anything but 1, so it is already simplified. All right, so we're going to go ahead and do another example here. We have 8.5 plus 3/5. So let's take a look at those new numbers. So we would get 8 and 5/10 because 2 and 5 both multiply to 10. So if I take 1/2, I know I want to get to 10, so I multiply by 5 over 5 and I get 5/10. And then 3/5 also needs to get to 10, but this time I'm multiplying by 2 over 2 and I get 6. Remember, this isn't multiplying by 2, this is multiplying by 2 over 2. So now notice I don't do anything to the 8. I'm not changing the 8. I'm not creating more whole groups. I'm just taking it and saying, okay, well 5/10, 1/2 is the same thing as saying 5/10. And 3/5 is the same thing as saying 6/10. And now I can work with these two numbers because they're like fractions. So I have 8 and 5/10, and I'm going to add 6/10. And I know that when I do that, I get 11/10, and then the 8 is by itself. But 11/10 is improper, so I have to change that improper fraction to a mixed number. The divisor goes on the outside, dividend on the inside. 10 goes into 11 once, with 1 left over. So I make one whole group with 1/10 left over, one piece out of the 10 that I need. But remember, I still have this 8. So this 1 gets added to this 8 because I made another whole group. So now I have 9 whole groups and 1 out of 10 pieces left over. And we can check our answer, and we are correct. All right, last we try problem. So we have a subtraction problem here. So again, we still have to make like denominators because they're not like. I know 5 can actually multiply to 10. So this is one of the scenarios where if you would have multiplied and done 5 times 10, you would have gotten 50. And those are large numbers to work with. And we like to try to avoid working with larger numbers when we don't have to. So in this case, I'm going to keep the 1 and 3/10 as it is because I can change the 5. So I can change 1/5 to tenths by multiplying by 2 over 2, and I get 2/10. So now I have 2 and 2/10 minus 1 and 3/10. Well, when we go to subtract, what do you notice is a problem? I can't take 3 away from 2. So I have to do what we call regrouping. Regrouping means we're borrowing. So we're going to borrow one whole group, and I know that one whole group in this case is equal to, because it's 10 as a denominator, one whole group means that I would have to have 10 pieces out of 10. So I'm going to take that one that I borrowed, and I'm going to turn it into a fraction and add it to my other fraction. So I have 1 and 12/10. Now I don't do anything to the bottom number because if I borrow down here, I'm going to have that same problem that I initially had. So just like when you borrow, so if I were doing 21 minus 13, this becomes one group of 10, and I take that 1 that's in the tens place and I move it to the ones place. Well, I know that 1/10 is equal to 10 ones. So that's how this becomes 11. So here, this 1 whole is equal to 10 out of 10. And that's what I added over here. So 1 and 12/10 is the same thing as 2 and 2/10. And to double check that, do your division. So you have 1 and 2/10. That 1 would get added to the other one, and you would have 2 and 2/10. So it's the same thing. All right, here we do 12 minus 3, which is 9. And 1 minus 1 is 0. So our answer here is 9/10. All right, this is just a review, so we did go through it a little bit more quickly. If you have questions, please remember to write them down. Email me and ask in class tomorrow so we can go over them. But otherwise, you have 4 problems here. You have 2 addition problems and you have 2 subtraction problems. One of the problems will require you to regroup. Just as a reminder, when you have to regroup, because we didn't see an example like this, so 17 minus 2 and 1/3. If that happens, this becomes 16, and then this is like having 0/3. So you would add the 3/3 to it, and so it'd be 16 and 3/3, so 16 and another whole group minus 2 and 1/3, so you can actually do your subtraction. All right, again, if you have any questions, be sure to email me or write them down so we can go over them in class.